Optimization problems in calculus often involve finding the maximum or minimum values of a quantity. Now, the steps involved in solving these problems are shown here. Now, step one is usually sketching. If you're not given a sketch, then you have to sketch it, sketch the situation to know what's going on. And then you write the equation for the quantity that you want to optimize. Then if your equation is not in terms of one single variable, then you need to rewrite that equation in terms of one single variable. And then after that, you need to take the derivative and use that derivative to find the critical points. How? Because if you equate the derivative to 0, then you'll be able to find the stationary points, the maximum and minimum points. Okay? Step 5, you justify that the points that you have from step 4, that is the critical points, represent the maximum or minimum. How do you do that? By using the second derivative. And then step 6, you just finish off the question. So I look at a problem here and just take you through those steps. So step 1 in this question, okay, we have a rectangular plot of farmland, and this plot is enclosed by 100 meters of fencing material on 3 sides. The 4th side is bordered by a stone wall, which means you don't have to fence that side. So find the dimensions of the plot that enclose the maximum area. So the first step is to sketch this situation, okay? So we need to sketch the situation. So which means we need to have a stone wall, okay? So let's have our stone wall here. And then, so this is the stone wall on this side. And then we have our fence. So our fence could be, we know that our fence is rectangular, which means this is 90, 90, 90, and 90. And that's equal to that, which means this is equal to that as well. Okay? So, what else do we know? We know that we have 180 meters of fencing materials on 3 sides. So what we can do here is that we can say, well, let this side be x, which means that side will be x as well. And because we have 180 meters of fencing material, this will be 180 minus 2x. Okay? And these are meters. So this is the situation. Now we can move to step 2, which is, remember, we want to find the maximum area. Okay? So our step 2 will be writing an equation for the quantity that we want to optimize. So step 2, write an equation for the quantity that we want to optimize. And this is the area, okay? So how do we find the area of this farm? So the area will just be equal to length times width, which is x multiplied by 180 minus 2x, which can FOIL that. Okay, so this is an equation for the area. Now we can carry on to the next step, which is now taking the derivative and finding the critical points, because we want to be able to know which value of x will give us the maximum area. So step 3, take the derivative and find the critical points. So the derivative of um, the expression for area, so that will be given by dA over dx. It will be, you just find the derivative of that, so 180 minus 4x. Okay. Now we know that critical points occur where this derivative is equal to 0. So we can write that statement below here and say that we know that critical points occur where this derivative is equal to 0. So we equate that to 0, which means we'll end up with 180 minus 4x is equals to 0, and 4x is equals to 180, which means x will be equal to 180 over 4, which is 45. So that's our critical point. So which means we need to justify that this critical point that we've calculated represents a maximum. Okay, so justify that this critical point represents a maximum. So that will be our step 4. So justify that the critical point represents a maximum. And you're going to use the second derivative test. Second derivative test. So we need to find the second derivative. So d2a over dx2, and that is, we just differentiate the derivative from the top, okay, which is negative 4. So what that means is that since the second derivative is less than 0, then a maximum point occurs where x is equals to 45. So since the second derivative is less than 0, we can say then a maximum point, so a maximum point occurs where x is equals to 45. Okay, so we have that sorted. Back to the question, what is this question really asking about? Find the maximum area. So we know where the value of x that gives us the maximum area. So step 5 is to find the maximum area. So the maximum area will be, we plug 45 in the original expression representing the area of this farm, that formula there. So which means you come over here and substitute that value of 45, this one here. So 180 into 45 minus 2 multiplied by 45 squared, and that will give you 4050 meters squared.